Okay, this is going to be my introduction to proofs. If you were in class, I kind of talked about the importance of proofs and why we're learning them in geometry class as opposed to any other class, because this is something that you could easily use in other classes, but it's harder to teach the logic in other classes because we don't have these hard facts that we can use to support our arguments in other classes. But in math, we do. We have all these hard facts. Okay, we have things that are always equal, things, specific properties and rules that we can use to solve equations and prove things about figures and numbers and all that stuff. So that's why we're learning kind of a logical system in mathematics class, and this is going to help you in any other thing that you do in your life, anytime you have to prove a point or make a case for something. So we're going to start with a real basic system for this. So when we're constructing an argument, we're in geometry class, we're going to do it in a very systematic way. So if we need to prove a conjecture is just a guess. So if I think that a certain property is true all the time, that's my conjecture. I'm guessing that it's true. In order to prove that, I'm going to have to show the steps to prove that it works every time, and every time I write down a new step, I'm going to have to support that step. I have to give a reason for it. And my reasons always have to be either a definition, so it could be a definition of vertical angles, which is something we've talked about, definition of congruence, definition of perpendicular, the definition of an isosceles triangle. Okay, any definition that we have we can use. We can use postulates. The only postulates we know so far are segment addition postulate and the angle addition postulate, but we'll get some more postulates in there. Any properties that we know from algebra or geometry, and we're going to go over a lot of properties today, or any theorem that we've already proven. So we're going to practice using algebra problems. So we're going to start by covering a few algebra properties. They're on page 96. I'm going to take a minute and just go over some of the algebra properties that we're going to use. So if I look at, an algebra problem, and I think about what I'm allowed to do or not allowed to do, you've heard all these properties before, but you weren't required to actually know what they were. You just used them. Well, now we're going to have to know what they are so we can support our reason for doing certain steps in our algebra process. So if I've got something like let's say I have some algebra problem like this. If I go through and start solving, every time I make another step, I'm using some algebra property. I just have to be aware now of which property I'm using. So the first thing I would do is I would distribute this 5 inside there, and I would get 5x minus 15 plus 2 equals 4x plus 8. Okay, so I distributed. Okay, I have to list the reason I'm allowed to distribute. Well, if you look on page 96, there's a property called the distributive property, which is something you learned a long time ago that you could do, but now we're going to have to list it out. Okay, I can do what I just did. The distributive property tells me I'm allowed to do that. And that's what a proof is. A proof is us doing what we know how to do and then explaining why we're allowed to do it. So you always have to imagine that there's somebody that's going to read through what you're doing, and they have no idea about math. But they have a resource. They have a big book of all the properties that go along with mathematics, and they don't believe that you can do what you're doing until they see that you have a reason for doing what you're doing, and that reason is going to be in their book. So the distributive property is something that they would be able to look up, and it would describe to them that you are allowed to do this. So that's proving that you're allowed to do that. The next step I would do is, on this side of the equation, on my left side, I can see that I've got two numbers here. I'm going to combine those. Okay. Now we're going to generalize all of our simplification steps into just simplify. Okay? So we're simplifying our expression. Okay, and simplifying our expression is something that he could look up in his book and see, okay, you can simplify expressions by combining like terms. Okay? But I don't want to have to write out combine like terms or, you know, reduce fractions, all that stuff. We're just going to lump it as a big simplify. So anytime you're doing something to simplify your expression, we're just going to write simplify. The next thing I would do is I would add this 13 over. Okay, maybe that's not the exact same step you would take next, but that's kind of the good thing about proofs. You're allowed to go in different orders as long as you just give me a reason why you're allowed to do it. So in order to get from this step down to what I would have next, okay, I would have 5x equals 4x plus 21. So the step I took to get this new statement is what I need to write over here. What did I do to get here? Well, I added 13 to both sides. I used the addition property of equality, which is also on page 96. Okay, you'll see quite a few properties on page 96 that are like this. You can add equal parts to both sides of an equation. That's the addition property of equality. You can multiply equal numbers or equal parts to both sides. The multiplication property of equality. You can divide by an equal amount on both sides of an equation. That's the division property of equality. Okay, and then you can subtract equal parts from both sides. Which is actually what I'm going to do next, because I need to move this 4x over. I'm going to subtract 4x from both sides. Okay. In order to do that, I use the subtraction property of equality. Okay, and then I'm done because I've solved for x, and that was my goal. My goal is to solve for x. Okay, so this is kind of the layout of a proof. We're going to start with these algebra proofs just to get into the habit of always justifying our steps. And then we'll slowly work into using geometry properties. Okay. There are some geometry properties that we're going to have to know. Okay, so I'll just get rid of the whole thing. So here's some new geometry properties that you haven't learned in algebra class. The first one is the reflexive property. Okay, that's allowing you to say that something is equal to itself. Okay, we can also say that it's congruent to itself by the reflexive property. Okay, which seems like a silly thing to use, because of course something is the same as itself. You know, that's why it is itself. But this is something that you are going to have to use, and you'll use it quite frequently. So you can use it for segments. You can use it for the measures of segments. You can use it for angles or the measures of angles. Okay, so this works for congruence or equals. Symmetric, we really won't use this one. But what it says is, if you've got something that equals something else, then it's also equal in the other direction. You can flip it across the equal sign. This also works with congruence. This one is a big one, transitive property. We're going to use this a lot. You're going to see it all year long. Basically, what it says is, if I've got x and x equals y, but then I see that y equals z, that means that x also equals z. Because x and z equal the same thing. Therefore, they are equal to each other. Okay, so anytime you follow a trail like this, well, x goes to y goes to z. Well, I'm going to cut out the middleman and just say x goes to z. That's transitive. And again, this works with equals or congruent. So I can say I have equal segments. The length of AB goes to CD, CD goes to EF, so AB goes to EF. Or I can say if I have congruent statements. Okay, I can use transitive there too. This is congruent to that, CD is congruent to that, AB is congruent to EF. Same thing with angles. Okay, so these are new properties, and these are the ones we're going to be using in proof. So I'm going to stop this video. The next video, if you guys want to see a bunch of examples of proofs, the next video you're going to want to watch is just beginning proof examples, is what I'll call it.